Guess I can zoom too, huh? How are you guys?
Find a study or more than one study.
Right. That's the quiz. Well, that's okay. And so start the day with that. That point right there. Start the day with that point right there. So I posted a project, and I think it was two quizzes this week. I'm going to try to get 3 up for you guys next week so you have some choices. Chris brings up a very good point, right? If you don't like a quiz, you can basically do that to it. Now, you don't have to print it out and scrumble up if you don't want to. Just don't do it. Just ignore it like it's not even there. I will still post a solution video to it as soon as, I think tomorrow I'll have time to actually go and make videos for the new ones and put the old ones up that I already have. But you don't have to do the ones you don't like. The only, that one is less Math 244 and more just being able to read critically into a study. Because, and we've been talking about this, those of you who had me in 105, we've been talking about it since 105. If you had me in 243, we talked about it in 243. But as soon as you apply a margin of error to a test statistic, if intervals then overlap, you no longer can make a conclusion based on the overlapping intervals. It's only when the intervals don't overlap that you can make a conclusion. And that was the point of that quiz, was find some where they do overlap and find some where they don't. And that's why I said a study or more than one study. Sometimes you get lucky, and if you grab a Gallup poll or a Rasmussen or a Quinnipiac poll, they'll actually have both examples within the same one, and sometimes you don't. That's why I said more than one. Now, you can do it here, but I did put one on the exam that you have to do, which is similar. So, but this is the thing. You're groaning. It's actually probably the easiest question on the exam, and there's not much math on the exam as it is. It's just a matter of going into the news and looking for intervals that overlap versus not overlapping. So, by all means, don't turn that quiz in now, but by the time the exam's due, you'll have a comfortable, and I've got a nice spreadsheet that I've built, a Monte Carlo simulation that we're going to start with in a couple minutes that I think will even help the idea drive home even more. Not to mention the fact that we're going to keep doing it for the next, I don't know, 8 weeks, 7 weeks. 7 weeks? My God, you're 30% done after today. Makes my head sad.
It's not like I spend all my time looking for polls, so that's the whole thing.
That's okay. You won't have to spend much time. Guaranteed you'll find one right off the bat where they make a claim that's not supportable. But then all you got to do, and here's the thing too, there are little key words you can look for. Like if you see something like the majority now believes, almost indefinitely I would put smart money on the fact that they don't necessarily believe, because it's like 51% with a 4% margin of error. Well, right there, that might not be a majority, right? Because 51% plus or minus 4 drops below 50. It potentially can drop below 50. So if you see something like, you know, new low, here's one of my other favorites too. There's a new low in the percentage of Americans who trust the government. It was 12%, now it's 10%. Okay? And those numbers aren't too far off from what it actually is. But if you apply 12 and 10% with a 3% margin of error, you can't tell which one's on top, right? Because the 3%'s too big. So you don't have to look very hard. And then, so that's the ways to find the ones that you can't draw a conclusion from. Look for keywords like new low, new high, majority. The ones that might actually show, look for crazy high percentages. Like jumped from 57 to 86%. Like that's a pretty obvious. Unless you've got like a 20% margin of error, 56 and whatever I just said, 80, they're pretty far apart from each other. So you don't have to look very, very hard. It's usually trickier to find the ones that do show non-overlap than don't. I just said non-overlap, didn't I? I could have said that easier. Ones that go like this are pretty easy to find. Ones that go like this can be a little bit trickier to find, but they're there. You don't have to look very hard. Usually if you stay in a Gallup site and just, oh, let's see how the president's doing. Oh, let's see how Congress is doing. Oh, let's see how we feel about ISIS. Oh, let's see how we feel, what's something, Measure 92, boom, there's a good one for you. I've been following this one for about a week now because I make it my 243s analyze. Have you guys seen that map, the interactive map that they've made for Measure 92? You know what I'm talking about, Measure 92?
GMO?
The GMO labeling. It's in Oregon, correct? I just found this out. It's in Oregon. It's nationwide. It's got nationwide attention, though. Let me find the map for you guys real quick. I didn't realize the map was interactive. Measure 92 interactive map. Let's see who's pouring. Is it Oregon lot? Here it is. I think this is it.
I see commercials of farmers opposing this every day on TV.
Opposing the labeling?
Yeah.
Like they're in favor of...
Like it's a farmer
They said
talking
it
for
costs-
30 seconds saying this is going to ruin our family, blah, blah, blah.
I got you. I see what you're saying, Chris. And I haven't... This all started very innocently for me. Oh, God, look at that. Okay, we'll come back to this in a second. So, this map I saw about a week ago. It did not look like this. It looked close to this. The circles have gotten much bigger since last week. So the circles, this was a 243 question. They're going to actually answer this on their exam in a couple weeks. You guys have an exam posted for week 5. They do too. You guys remember, maybe you don't. It's totally fine if you don't. But it's worth going over again in 244. When you present data, you have choices on how to present that data, right? You have choices. The data in this map ostensibly is representing the amount of contributions going in to oppose GMO labeling. So no, we don't want GMOs labeled. Yes, we do want GMOs labeled. So how much money, in a ratio, how much more money is being spent to say no than to say yes? Ballpark it.
Twice as much.
2 to 1. That ratio has shifted like 12 times over the past week. When I first took a screenshot of this map and put it on the 243 exam, it was 5 million to 2.5 million. It was still 2 to 1. Yesterday, it was 7 million to 5 million. Then it became roughly nowhere near 2 to 1, and now it's back. And I'd be curious, I think I know who's pouring the money in. You know who's pouring a lot of money into this? You guys know Dr. Bronner's? Look at the contribution. Dr. Bronner's makes natural soaps. You can get them at REI, I think, get them at Mountain Supply. Little local stores will carry them. They usually use really cool ingredients like peppermint soaps and things like that. Really rad stuff. If you have skin allergies, they're really pure. I mean, if you follow the amounts, I mean, look at that one, 500,000. A sizable chunk of the total is coming from Dr. Bronner's. And if you follow them down, they start very, I shouldn't say start, 4038 just came in into September. I don't exactly understand the timeline of why the company, there's actually an article written, Dr. Bronner's supporting Measure 92. It's actually really cool. It's got the owner next to a vat with a big paddle. Very fun to read. But anyway, these circles now look more like they did last week. Yesterday, these purple ones were much smaller. Now, my point for 243, I'm not contesting the numbers. I mean, the numbers are interesting. Look at that, 1.2 million coming from Dr. Bronner's. If you click on purple, Monsanto's put in 4 million. Now that makes perfect sense, of course, it makes perfect sense. So I'm not contesting the numbers up here. I'm not contesting the numbers. What's interesting though, individual contributions to the No campaign, $500. Individual contributions from the Yes campaign, about 2/3 of $1 million. And that's up from 500,000 yesterday. So it's fun to see how those numbers play out. But I'm not even worried about that. I'm worried about how these numbers are being represented down here. Can anybody see an issue? I'm going to shrink it down a little tiny bit. Oh, I can't, never mind. I'm zooming out to the world. I wonder if I can do it on the page I'm out here. Okay, there we go. Can anybody see a very simple mathematical / statistical error that the map maker has made in how they're presenting the data? And you learned this in 243, it was like, God knows, 30 weeks ago, 40 weeks ago, you may have forgotten this. The same mistake was made when you guys took me in 243 with the debt balloon problem we looked at. You might not have looked at it because it was in the extra resources page, but the debt balloon was a perfect example of this. The truncated axis on the Obamacare quiz that you guys may or may not have done was related to this. The should I pull the feeding tube from Terry Schiavo's belly was related to this. It's all tied back to the same mistake, and this is what I love about statistics. The same unfortunate mistakes keep happening. Can anybody catch the mathematical error?
Does it have to do with the circles going into the original?
That I think is okay because the circle is centered on the zip code that they're talking about. So when I clicked on this purple one, Elizabeth, that means that's the zip code and that's where Monsanto's headquarters is. So, and then when this green one, this big green one right here is centered on Vista, that's where Dr. Bronner's is. Portland, if you notice, Portland's got a bunch of nested circles. And I'm really glad I got this map a week ago and not now, because now there's a buttload more circles I had to extract out of the image, so I'm glad I did. But the problem is the circles. When you're trying to find, you guys just told me, it's a 2 to 1, right? Purple to green, 2 to 1. So shouldn't there be twice as much purple as green?
Yeah.
That makes sense, right? If you're looking, the problem is, approximately how much more purple is there than green? Can you tell? Well, that's tricky too, but even if they didn't overlap, can anybody have a guess as to how much more purple there actually is than green?
It looks like they're pretty close to equal.
They're not, a lot of this is because they're super nested on top of each other though. It's 4 to 1. It's 4 to 1, not 2 to 1. And the reason is because they used a two-dimensional object to stand for a one-dimensional number. They used a circle. See, here's the deal. Here's the deal. If you actually, this is tricky, this is very subtle, and don't tell my 243s because this is their problem for the exam. Of course, I walk them through, and I'm about to walk you guys through too. If you actually measure the diameters of all these circles, measure the diameters of all the circles, and I tell the kids, grab a ruler and put it up next to your computer screen. And there were far fewer circles for theirs, thank God. They'd hang me if there wasn't. If you measure all those purple diameters, and then add up all those numbers, and then you add up all the green diameters, and add up all those numbers, and you divide the purple sum by the green sum, you will get roughly 2 to 1. It's almost spot on 2 to 1. It's exactly right, as it should be, right? But then, instead of representing it with a straight line, they swung it out and made a circle out of it. That introduced a second dimension. And if you remember the formula for the area of a circle, which you might not, that's okay. Yes, there's a squared in there, remember? So depending on, do you guys do pi r squared or pi d squared over 4? Pi r squared, that makes the most sense. So, and the radius would have the same effect as the diameter. If you measured the radii and added them up, and measured the radii of the green and added them up, it'd still be 2 to 1. So the radius of the purple to the radius of the green is definitely going to be in a 2 to 1 ratio. Hopefully that's fair. But when you look at the ratios of the areas of the circles, you get pi times the ratio of the purple squared over pi times the radius of the purple squared and the radius of the green squared. Pi's cancel. And you have this, the ratio of the purple over the ratio of the green, all squared. Well, that's 2 to 1. But when you square it, it becomes 4 to 1. They made the same exponential mistake that map makers often do by trying to be clever. I'm sure what they're trying to do is like bullseye on the donations, right? That's very, very clever. Unfortunately, you also you exaggerate the difference. How many people's eyes are drawn to this first and that second? Mine were. Yeah, mine were. I mean, I'm being honest, mine went right to the colors. I mean, shah! And then I was like, oh, there's colors up here too. And then I'm like, wait a minute, because I'm trained to look for this kind of stuff. But how many Americans are trained to look for that kind of stuff? I think you guys are in a small subset of those Americans, right?
Well, we're used to maps being associated with location, so it implies that, like,
Yes.
those states are...
Yes, not a zip code, but the state, the boundary with the state, which in fact Elizabeth was talking about too. This purple, I mean, if you think about this purple, it's like, oh my God, Kansas. No, Kansas has nothing to do with that circle. I think a better, if you could do this with a map, a better thing to do would be to, you could do this, lay the map down three-dimensional and have the amounts come out linearly from the zip code. That would be a better way of doing it, because then you keep the straight lineness, you forget this painted location bit, and you'd avoid the radial difference. That actually would be a much slicker way. I should email the guy and tell him. Maybe I will. I'll be that guy. Hey, dude. So anyway, this is the kind of stuff that I train all my stat classes to look for. And that's that quiz too. I mean, I apologize you didn't like it. That's totally fine. You don't have to like it. But the idea